we're going to look at how to use a graphing calculator to solve equations that mix trig with algebra, with exponential expressions, things that we can't solve by hand because there's no way to really get x by itself because the x is tied up in a trig function or off by itself or in an exponent. And the first step is to always first recognize that that's what you have to do. So anytime you see a mixture of trig with algebraic type expressions, algebraic means like just x to a power or something like that, then you know you have to bust out the old graphing calculator. And step one is to get one side of the equation by itself. So I had done that here by subtracting x from both sides. I could have also gotten the other side to equal 0 if I wanted to. I just was more comfortable subtracting x. Step two is because I'm dealing with trig, make sure my calculator is in radian mode because that's how we do math. So I'll click on the mode button here, and I will see that I'm in radian mode, but if I wasn't, I would use these cursor keys to highlight it and change that. And now I'm going to go ahead and graph. So if you've never graphed before, it all starts here with this y equals button, and then we're using this to put in our variables as we go. So I'll type in 2 times the cosine of x, close that parenthesis off, subtract x, and I'm going to graph it. And I want to know when this graph has a y value of 0. This is the graph of y equals 2 cosine x minus x, and I want to know when that y value is 0. So basically, I want to find that x-intercept. There's a wonderful feature here. We're on step 3 now. Use the second calc 0 feature. Second calc is all up in here. There's lots of things the calculator can calculate for you. If I press second calc, I want to find that 0. So I'm going to choose option 2, find the 0. And the calculator is going to ask me for 3 things. It's going to ask me for the left bound, the right bound, and the guess. Basically, the calculator is asking me, where do you want me to look for this answer? Where do you want me to look? And I want to look around here for the 0. So it's going to say, what's the left bound? Here's my little bug. I use the left and right keys. I want to make sure I'm to the left of that 0. Right now, I'm obviously to the left of the 0, but I could be closer. So I'm going to move a little closer. Oh, maybe too far. So I'll go back a little bit. I want to make sure I'm to the left of it. I'm sure I'm to the left of it there. When I press enter, you'll see this left bound turn to the words right bound. Watch. Here I click. Keep your eye on the left bound part. I'm going to click enter. Now it wants to know the right bound. And it put a boundary line saying, okay, I know that this line is definitely to the left of the 0. Can you now give me a right boundary line? So I'll go to the right of the 0. So that might be to the right, but I'm going to go a little more just to make sure I'm definitely to the right of the 0. And when I click enter again, that right bound will turn to the word guess. Give me your guess. So I'll click enter, click. It puts up a right boundary line, and we're telling the computer, or the calculator, our 0 is between these 2 lines, and I think my guess is that it's right about there. Maybe. So I'll click enter, click, and I was like, okay, man, your 0 is at 1.0298665. So we can take this answer and we can either round it or truncate it to 3 decimal places. Rounding it to 3, this 8 would make this 9 go up. This basically makes this 29 go up to 30. So 1.030 would be rounded to 3 decimal places, or 1.029 is going to be truncated. When you truncate, you just lop off everything past the 3rd decimal point. I don't care which one you do, so you can report 1.029 or 1.030. They're both fine answers, but that's the 0 of the function. In this case, it's probably going to be more accurate since that 9, that 8 is so close. I'll use 1.030, but like I said, it doesn't really matter. So x equals 1.030. And I'm done with this problem. If I wanted to double check my work, I would take this value and plug it into this x and do this calculation, 2 times the cosine of 1.030. And I would take this x value and plug it into this x, which is just itself. And these 2 sides would be pretty close to equal, not quite. Like we rounded, so it'll be off a little bit, but that's basically it. These are the steps we follow to do this process. The buttons are second, calc, option 0, give it a left bound, give it a right bound, guess, and you're going to be good to go. Give it a try. Whoa,